For this experiment, we will be having a person jumping off 3 different heights. This is to prove that gravitational potential energy equals to kinetic energy. The reason we have 3 different heights is to prove that height makes a difference in the velocity of the fall from the jump, and that it has a difference in the overall gravitational potential energy and kinetic energy. Additionally, this practical would also be linked to Felix B's supersonic jump from space, as he also jumped from a platform. The only difference between our experiment and Felix B's height is that he jumped from space. This practical will be linked to an exam-style question as well. This experiment will include a person jumping off 3 different platforms. While the person is falling, the fall should be recorded on camera to conclude a velocity value from the jump. As the jumper's feet has lost contact with the platform, the time starts and stops when the jumper's feet are in contact with the ground. For safety reasons, a cushioned mat will have to be placed on the ground of the platform to lessen the impact of the jump towards the jumper. Due to this, the height of the mat should be measured so that the height of the jump can be accurate. For example, if the length of the mat is 3 centimeters, then the platform should be at a height of 5.03 meters, if the jump height is meant for 5 meters.
With this experiment, there are many important variables that need to be considered. Firstly, the weight of the jumper should stay the same throughout the whole experiment. This would mean that the jumper that jumps off platform of 1 meters should also jump off the platforms of 3 and 5 meters. By having the same jumper with the same weight conduct the entire experiment, a more accurate result would be achieved because mass affects GPE and KE, which we will explain later. To further increase the accuracy of our results, 3 jumps from each height should be conducted to spot any anomalous results. Although the person that is jumping off the platforms are referred to as the jumper, he or she should not jump off the platform. Rather, they should walk off it. This is to avoid any unnecessary extra height gained from the jump, which would affect velocity and the amount of gravitational potential energy, since gravity has more time to act on the falling person. To summarize, the mass of the jumper must stay the same. This experiment includes 3 jumps with different heights. By having 3 heights, the GPE and KE would change because of the difference in heights. As the height change affects the final value of GPE and KE, the height would be considered the independent variable, and amount of KE and GPE would be the dependent variable, since it is affected by the change in height.
This is from 3 meters. Oh my goodness.
Walk off.
Just keep going. Alright, that's one.
Our experiment is to prove that gravitational potential energy equals to kinetic energy. But how does it equal in the first place? To start off, we should talk about energy transfers. There are 8 types of energy, and all of these types of energy transfer to another. All 8 of them, and the total amount of energy would stay the same during each transformation. That's how GPE can convert to KE. But why is there such a relationship between GPE and KE? We should talk about GPE and its qualities first. Gravitational potential energy is the energy of an object that has because of its position. The higher the position, the more GPE it has.
Okay, so here's an example, right? Higher the position, the more GPE it has. So this person right here that weighs 60 kilos is standing at 50 meters, and this guy right here, also 60 kilos, is standing at 20 meters. So obviously, because of the position of A, this guy would have more GPE than B.
From the example above, there is a person standing on 2 different heights. Because GPE is the energy an object has because of its position, and because GPE is greater the higher you go, A would have more GPE compared to B. The reason is, A has done more work against gravity to reach that point, thus possessing the superior GPE. However, the person A is only higher in GPE than B if they are both the same weight. If A is lighter than B, it may be possible that B has a higher GPE value in joules than A. This is because more work would need to be done against gravity if mass is higher. This leads us to the GPE equation. Gravitational potential energy equals mass times gravity times height. In short, GPE is the amount of work needed to be done against gravity to achieve potential energy. Let's try to apply GPE equation to our previous example.
Okay, so if we apply the GPE equation to our example, which we talked about previously, if we apply it to our example here, GPE of A would be 60 kilos, that's the mass, here right there, and gravitational field strength on Earth, 10 newtons per kilogram, and times 50 because of the heights, and that's 50 meters in height. And that would equal to 30,000 joules. For B, see that it's inferior height to A, so it will be 60, but that weight is, the mass is still the same, times 10 newtons per kilogram, and times 20 because that's the height, and that equals to 12,000 joules. So, as expected, the superior height of A gives it more gravitational potential energy, and this is because A has more work against gravity by climbing a superior height. Now, this GPE example has different heights but the same mass, but if we change the mass of the people that are on the building, it'll look something like this. So, we change the mass to this person to 160 kilograms. GPE of A would be still the same because the mass and height is unchanged at 50 meters and 60 kilograms, so that's 30,000 joules. GPE of B, however, because of that changed mass, we had to change it from 60 kilos to 160 kilos because that's how much he or she weighs. The gravitational field strength and the height obviously is still the same, but as you can see here, GPE of B is 32,000 joules and 30,000 here. This is because, as with height, more work is needed to climb against the gravity with the increased mass of the person, so, despite the inferior height of 20 meters compared to A right here. Now to summarize, gravitational potential energy can increase with mass and height. So the higher you are, the more GPE you have, and the heavier you are, the more GPE you gain in comparison to a lighter person, as more work needs to be done in order to reach a height.
Moving on. Kinetic energy, or KE, is the energy of a moving object, like a car, or a falling rock, or like me. The faster the object is moving, the more kinetic energy it has. Kinetic energy, like GPE, has a relationship with mass. Since KE is the energy of a moving object, and more mass equals more momentum, and more momentum equals more velocity, mass is a considered variable in KE. Going back to the definition of KE, it is the energy of a moving object. Like me right now, I'm moving. Any moving object must have a speed, or else it wouldn't be moving, right? Therefore, velocity is also considered in KE. Although it is logical to have speed instead of velocity, there aren't many differences between speed and velocity. It's just that speed is just speed in any direction, and velocity is in a certain direction. Alright? Because of these factors, the kinetic energy formula would be half times mass times velocity by the power of 2. Okay. I repeat, half times mass times velocity by the power of 2. If you backtrack the GPE and the way it achieves its potential energy, it is the amount of work done to be able to gain height, as work needs to be done against gravity's force to reach a certain height. As GPE transfers to KE, the amount of work done transfers into KE, and thus it will be equal under the law of conservation of energy, which states that the total amount of energy stays the same during each energy transformation. So that's why GPE would equal to KE. Think of picking up a rock and dropping it, or a roller coaster climbing and then diving, alright? GPE is like climbing a building, right? And KE is like jumping off the building. So, alright, if you come here right now, I've got an example for you. So, GPE would be climbing this, because look, this is a roller coaster, right? So work needs to be done against gravity to gain GPE. At the peak height, it is the highest GPE, and once it's coming down, it's increasing GPE, and near the end it is its highest increasing KE, and at the bottom it's the peak KE, because it's coming down and it's got lots of speed, and the gravitational potential energy is transferring to kinetic energy, and that's it.
Okay.
Because kinetic energy is the energy of a moving object and GPE is the energy of an object because of its position, GPE and KE would have an inverse relationship. For example, when an object is lifted to a height, it gains more GPE, right? But as the object is dropped, the GPE would convert to KE, and thus the GPE would decrease and the KE increases. This would be an inverse relationship. As one goes up, the other goes down.
Practical and the explanation behind it can answer many physics exam questions. The one that we will be using as an example will be this one. So, the question asks for the decrease in gravitational potential energy, which basically means how much GPE is used up from when the child was on the top of the slide. And yeah, top of the slide to the bottom of the slide. That's the decrease in gravitational potential energy. It gives all the information you need to figure out the GPE. Alright? So, it gives all the information. It says here, a child of mass 18 kilograms, that's mass. If you can recall, the GPE formula is mass times gravity times height. So, we've got the mass of 18 kilograms, the gravitational field strength, 10 newtons per kilogram, and the height, which is 2.5 meters. So we apply that to the formula here. Gravitational field strength equals mass times gravity times height, and 18 kilograms times 10 newtons per kilo, so that's 10 times 10, which is the gravity, and times 2.5 because that's the height of the slide, and that would equal to 450 joules. What we've just talked about is all very related to Felix B's jump from space. As impractical is related to what he did. Now, if you come here to our diagram of his jump, energy transfer and air resistance is all very deeply involved into his jump. Now, firstly, he would need to travel up a distance of 40 kilometers of altitude, which would take a tremendous amount of work and energy. Now, when 40 kilometers of altitude is reached, the amount of GPE at that point is extremely high. Assuming that Felix was 73 kilos when he jumped from space, he would have had 29 million joules of gravitational potential energy. The instance that Felix jumps off his space capsule, the GPE rapidly transfers to KE as Felix is now in motion. Now, Felix opens his parachute during the jump, but if he free fell 40 kilometers of altitude, like if he just didn't open his parachute at all, he would have been at speeds at around 600,000 kilometers an hour, assuming that there's no air resistance. His 29 million joules of potential energy was only transferred to kinetic energy for 4 minutes and 20 seconds, but that was enough to break the speed of sound. If Felix B never opened his parachute, he would have broken the speed of sound nearly 500 times, all because of GPE and KE.